Let's do some examples using the inverse sine function. Just as a reminder, remember that the domain for the inverse sine function, let me change this color. The domain for the inverse sine function is between -1 and 1, as you can see here on the x-axis, and the range, which is your output, is from -π/2 all the way to π/2. Okay, we're going to use this to find these answers. And range is the output, domain is your input. Let's see some of these. My first example here is sine inverse of 1/2. So the input is 1/2. This is a value that I would find on my x-axis, right? It's an input, and it is between -1 and 1. So this is a valid input. Okay, so where is the sign equal to 1/2 on my unit circle? If we go to the unit circle, if you don't know this by heart, you should memorize it. But if you don't know it, let's locate 1/2 on the unit circle. And 1/2 is your y coordinate. Okay, remember sine is always your y coordinate. So I'm looking for the angle whose y coordinate or whose sine is equal to 1/2. So here I found one. Here's sine equal to 1/2. Where else is sine equal to 1/2? Here also. I have a y coordinate of +1/2, and down here they're negative. So I have two possible values. Which of these do I say this is equal to? Am I going to say this is equal to π/6, or am I going to say that this is equal to 5π/6? Now that's a very important question. The one you're going to pick is the one, remember we're looking for your output, and we said our output has to be in between -π/2 and π/2. So if we look at that on our graph, it means I cannot choose any value that falls out of this range, okay? So 5π/6, that will fall out of +π/2. Notice 5π/6 is greater than 5π/6. Greater than π/2. 5π/6 is a number that is greater than π/2. So that number would be somewhere all the way up here somewhere. That would fall outside of the range. So I cannot choose this value as the answer to my first example. I have to use π/6 because π/6 is within the range that I'm supposed to be, okay? And also remember that -π/2 to π/2 will represent this piece of the unit circle. From here all the way around to here. Okay? And I had said in the last video that 11π/6, that is way, way, way up here on my y-axis. I can't use 11π/6 or 7π/4 or 5π/3 or 3π/2 as outputs for the inverse sine. And we had said that instead of using 11π/6, we're going to use -π/6. Okay, so whenever we need to reference this angle, we're going to reference it as -π/6. Instead of 7π/4, we're going to say this is -π/4, okay? Instead of 5π/3, we're going to say -π/3. And instead of 3π/2, we're going to say -π/2. So keep this in mind for your sine function. Let's do the second example. Inverse sine of square root of 2/2. What this is asking is what is the angle that I take the sine of and get square root of 2/2? Okay, so let's look at our unit circle. Where is square root of 2/2? Remember, sine is your y coordinate. So now that I know that I can only use this section of the unit circle, I'm only going to look in this section for this answer. So let's look at all our y coordinates. So here they are. Square root of 3/2, square root of 2/2. Here I have a possible answer, right? And let's see over here. Oh, I have square root of 2/2, but it's negative. So this one is not going to work because they're talking about the positive y coordinate. So I'm on the first quadrant here. So what angle corresponds to this sine? Here it is, pi fourths. So this is equal to pi fourths, okay? Notice your input, square root of 2 over 2, is within this range, and your output is within this range. So it's all valid. The sine inverse of -1/2. Okay, we know sine has to be in between these two quadrants, either quadrant 1 or quadrant 2, okay? So what angle, when I take the sine of that angle, will equal -1/2? Let's look. I know that in the fourth quadrant, all of my y coordinates will be negative. So I know it's in here somewhere, okay? I'm not even going to look in the first quadrant because your y coordinate on the first quadrant is positive. And this says -1/2. So it has to be in the fourth quadrant. And here it is. It corresponds to the angle 11 pi 6. But remember, I can't use 11 pi 6 because 11 pi 6 does not exist in between -pi halves and pi halves. That is way above pi halves. It's outside of the range of this graph. So I'm going to use -pi 6 instead, because -pi 6 does exist within this range. It's probably about here, -pi 6. Okay? Next one. Inverse sine of negative square root of 3 over 2. Again, it's negative. It's the y coordinate, so it has to be in the fourth quadrant. And here it is. It's 5 pi thirds. But we cannot say it's equal to 5 pi thirds because, again, 5 pi thirds is way outside of the range for the inverse sine. So I use -pi thirds, which, if you take the sine of -pi thirds, you will get this answer. And -pi thirds is about here. Okay? So it's within the range that I'm permitted to use. Sine inverse of 1. This is asking you what angle, when I take the sine of that angle, gives you 1. Where does that happen? At what angle? So this is a positive number. This is sine. Sine is your y coordinate. Where is your y coordinate positive? In the first quadrant or the fourth quadrant? It's positive in the first quadrant. So I have to find my answer within these values here that are positive y coordinates. So where is the sine equal to 1? Here it is right here. Sine will equal 1 if the angle is pi halves. And pi halves is within my range, so I can use pi halves. Okay? Now, be careful. What if I ask you, what is the sine inverse of 3? Okay? Be careful. Remember, this is your input for the inverse sine function. Our inputs are our x values. So let's look at the graph for this. These are my inputs on the x-axis. And we had said that our inputs will go only from -1 to 1. That means my graph exists only within this domain from -1 to 1. 3 is a number that's outside of this domain. 3 would be somewhere down here on the x-axis. This value, when you look to see what the output is, when the input is 3, the output does not exist because there's no graph beyond these two endpoints. So for this, we say that it's undefined. It doesn't exist. And if you try to find this on your calculator, it's going to say something like syntax error or math error or something. It's not going to give you back a value. So be very careful with this. Okay, when you don't have values that you recognize from the unit circle, you have values like 3 or 5 or 10 or -8, make sure to quickly notice that these values cannot be greater than 1 and they cannot be less than -1. For my next video, we're going to do composite inverse trig functions using sine and cosine and other ones, okay? So we will do another video on that, and then we'll talk about the other trig functions. I'll see you in the next video.